Hello and welcome everyone to my presentation. My name is Sheila Dervis. I'm a master's student at the University of Ottawa in Canada. And the topic of my discussion today is large differences in body fat do not independently alter thermoregulatory responses. As previously shown in today's conference, a paper by Jay et al. In 2011 compared two groups with about a 20 milliliter per kilogram per minute difference in VO2 peak, but their mass and body surface area were matched. They had the participants exercise on a semi-recumbent cycle ergometer at the same heat production, and they noticed that the changes in core temperature and whole body sweat rates were the same between the two groups. So the VO2 max differences did not alter thermal responses during exercise. Another study recently published in 2014 by Kramer et al., a colleague in Dr. Jay's lab, looked at two groups with about 20 kilogram difference in mass and a 0.3 difference in meter squared in body surface area between the two groups. They had the groups exercise on a semi-recumbent cycle ergometer, again, at the same fixed heat production of 500 watts, and found that the small group had a larger difference in change in core temperature, but their whole body sweat rates were the same. And these results are in accordance with another study by Gagnon et al. That found that it is the evaporative requirements for heat balance determines the whole body sweat rates. So now we see body surface area affects thermal responses, mass affects thermal responses, VO2 max does not. But what about another really important physical parameter known as body composition, or your body fat? So that's what I'm looking at today. Currently in the literature, there are three main findings. An example of the first finding by Vogels et al. In 2011, they compared an obese and a lean group, and their differences in body fat were about 10%, which is not very big, but they found that the obese group had a greater peak core temperature and also whole body sweat loss. As you can see in the participants' characteristics, their body mass or body surface area were not normalized between the two groups, and they exercised at a relative intensity of percent heart rate max. On top of that, their metabolic heat production was not reported. The second main findings in the literature, an example by Limbo et al., found that the changes in core temperature between the obese and lean, which had a difference of body fat of greater than 10, they found that the changes in core temperature between the two groups were the same, as was the local sweat rates. They had their participants exercise at a fixed watts per meter squared, but again, as you can see, their body masses were not normalized between the obese and the lean groups. The third main finding that we found in the current literature, an example is by Leddies et al. In 2012, that compared two groups with a greater than 25% body fat, which is impressive. And they found that the lean group had a greater change in core temperature than the obese group, and the same response was in their whole body sweat losses, where the lean group had a greater whole body sweat loss. However, they had the participants exercise at about 55% of their VO2 peak. But if you take a look at their VO2 peak, the lean group had a greater absolute VO2 peak. So they were clearly exercising at a greater amount at a greater heat protection. On top of that, their total body masses were not normalized. So it's clear that in the literature, there are inconsistencies in changes in core temperature between the lean and obese groups and their whole body sweat losses. And this is due to primarily, percent body fat being confounded as an independent variable. And that's due because the large groups and the small groups, or the obese groups and the lean groups, were not normalized for their mass, body surface area, and heat production. Another method suggested in the literature in order to eliminate body fat as a variable is to prescribe an exercise intensity that elicits a heat production based on watts per lean body mass. Now, we rationalize that this would not effectively do so, primarily if we look due to the fact that if we were to take two groups in a lean and obese group, match them for their total body mass, have them exercise at, for example, 7.5 watts of lean body mass, the lean group presumptually will have a greater lean body mass, and that would result in a greater heat production per total body mass. So now this leads us into the research question, which is what is the independent influence of percent body fat during exercise at a fixed heat production when we account for mass and body surface area between lean and obese groups on changes in core temperature, sweating, and body heat storage? We hypothesized that body fat does not independently influence thermal responses during exercise when heat production is accounted for, body surface area, and total body mass are accounted for as well. So, a little too soon. So we recruited 7 lean and 7 non-lean participants and paired them. So just to give you an idea, this is an example of one pair. We have a lean and a non-lean. Their total body masses are almost identical at 94.8 and 94.7 kilograms. Their body surface area, again, are almost identical at 2.19 meters squared and 2.18 meters squared. What is different between the two groups is their percent body fat, where the non-lean person had 37.8% body fat. The lean person had 9.1% body fat. And consequently, their lean body masses were different, as was their average specific heat capacity of their tissues. So just to get the big picture of the seven pairs, their total body masses were the same, body surface areas were the same. What was different, again, percent body fat, large difference, greater than 20% difference in body fat, even though the two groups had the same total body mass. And again, as I mentioned, that resulted in large differences in their lean body mass and average specific heat. Now, how could we measure this? What would be the most effective way to measure this? And Ollie gave us a great speak about matching participants for heat production per kilogram. So we took 3 trials, 1 preliminary, 2 experimental. In the first experimental trial, we'll call it the fixed heat production trial, we had the participants exercise at 540 watts, which elicited 6 watts per kilogram of total body mass. And then in the second experimental trial, we'll call it the watts per lean body mass trial, they exercised at 7.5 watts per kilogram of lean body mass. The ambient conditions included a room temperature of 28 degrees Celsius, relative humidity of 20%, and air velocity of 1.0 meters squared from the 3-tier fan that you can see. The participants exercised on a semi-recumbent cycle ergometer. They were semi-nude, which means they wore standardized shorts and running shoes. And those were the conditions. So now for our results. If we look at the fixed heat production trial, the heat production based on watts and watts per kilogram were the same between the lean and non-lean group, as was their external workload. Now, if you take a look down at the graphs, on the y-axis we have the time of the exercise, which is 60 minutes, and on the y-axis we have changes in esophageal and changes in rectal temperature. It is clear that their changes were the same between the two groups. And then in the watts per lean body mass trial, their changes were very different, and as you can see, their heat production per lean body mass was the same, and their heat production per watts per kilogram was very different, where the lean group had a greater heat production per kilogram of total body mass. Now, for the evaporative requirement in the fixed heat production trial, it was similar between lean and non-lean groups. And if you look at the watts per lean body mass trial, their evaporative requirements were greater in the lean group, which resulted in greater whole body sweat rates in grams per minute throughout the entire exercise. If we look at local sweat rates in the fixed heat production, the watts per meter squared were the same between the two groups, which resulted in the same increase in local sweat rate in milligrams per centimeter squared per minute. And the watts per lean body mass trial, they had a greater heat production per watts per meter squared, and that resulted in greater local sweat rates. We calculated heat storage using partitional calorimetry, and then in the fixed heat production, it was greater in the lean. It was the same in the lean and the non-lean group. In the watts per lean body mass trial, they were very different, so it was greater in the lean group. And to conclude, the body fat does not independently alter thermoregulatory responses during exercise. And when core temperature comparisons between different groups in body fat, it should be performed using a heat production based on total body mass and not lean body mass. And just a quick thank you to the Aspetar conference and my lab mates. I didn't have enough time to thank everyone that I listed there, but you can read it.
Okay, any questions from the audience?
Jonathan Wingo, U.S. Just curious as to how you measure body composition. What method did you use to
We
get body
used
fat?
DEXA. We used a DEXA scan. Yeah.
Just because you were so quick. So you shouldn't look at lean body mass, but just at total body mass.
Pardon me?
You were so quick. So should we just look at lean body mass or just total body mass?
No, big picture,
Big
total
picture.
body mass,
Okay.
not lean body mass.
Thank you.
That is the take-home message.
Any other questions? Okay, I'll have a question. Do you think you would have had the same results if you were in a fairly temperate environment, 28? Do you think you would have had the exact same results if you were in a 35 or 36 degree
Well,
environment?
that's something I would love to continue and investigate further to understand what would happen in different in an environment that's non-compensable, or in between people that have a really, really big difference in body composition, or like someone that has like over 50% body fat, and compared to someone who's like really, really lean, just to get more extremes.
All right, thank you very much.
Thank you.